Welcome to Spring Lib.
So it's essentially asking us for linear velocity and radial acceleration. So we'll have our omega of 3050 RPM, 3450 RPM, revolutions per minute. And that could be 2 pi radians for every 1 revolution times 1 minute for every 60 seconds. And we have 361.283 radians per second. We have the diameter, so 0.208 meters. This is for the saw blade. Then we have D1. We'll just say D1 equals D, which is 0.208 meters. This is for the first pulley. Then we have D2 equals D over 2 equals 0.104 meters. This is for the second pulley. So we know that the V equals omega r, and we know that the angular velocity of the second pulley is going to be twice that of the first pulley. So V is going to equal 2 omega times r, 2 times 361.283 times 0.104, and this is going to give us 75.147 meters per second. So this is extremely important that you realize that the linear velocity of the second pulley is going to be twice that, rather the angular velocity of the second pulley is going to be twice that, the angular velocity of the first pulley. So when you calculate the linear velocity of the second pulley, you have to substitute 2 omega for omega. And then they're trying to find the radial acceleration. So the radial acceleration is simply going to be equal to 2 omega again, squared r. This would be the general formula. However, we have to plug in 2 omega for omega. So it'd be 2 omega quantity squared times r. And we have 4. And this is going to be equal to 5.43 times 10 to the 4th radians per second squared. So this would be your answer for A. This will be your answer for B. And that's the end of the solution. Thank you for watching.